Okay, let me show you an example of calculations and creating a box plot. And this time I will not use R, I will use just a pen. And imagine that we have a sample, 10 glasses of water from a lake, and we measure it how much of chloride in each glass. So we ended up with these 10 numbers that I have written down. This is a chloride concentration in milligrams per liter. Let's do some calculations first. So let's calculate the sample's quantiles. So we have n equal to 10. So, and let's write down the position. So we have first and second and third, fourth, fifth, sixth, and so on. So these are positions of the numbers. We will use, we know that n equal to 10, and we know the formula. So if you want to calculate this, we need to take I minus 0.5 and divide it to n, where I, it's a position, okay? So I'll try to write this down. 1 minus 0.5 is 0.5, then we have 1.5, then we have 2.5, 3.5, 4.5, and so on. 6.5, 7.5, 8.5, and 9.5. Okay. Now we divide it to 10, every number, and then I will just write down in percent. So 0.5 divided to 10, it's 0.05, so it gives us 5%. Then, like, similarly, we have 15% here, 25% here, 35% here, 45%, and so on. I'll just write this down. And of course this is 5, not 8. So 75%, 85%, and 95%. Okay, so these are samples quantiles. Now this next step is to find the quartiles and statistics. So we know that this is the minimum, the smallest value. This is the largest value. Now the first quartile, it's a 25th percentile. Luckily we have it here, so this is the first quartile. It's 61.5. Then 75% is here, so this is our third quartile. It's 71.5. And then we don't have a second quartile, we have to calculate it. But luckily the second quartile is just in between, so we can just calculate it as an average of these two values. So this is the second quartile, and we'll just write down it here, 66.5. Okay. So the next step is to calculate interquartile range, because we want to identify if we have any outliers. We know that interquartile range is just the difference between the third and the first quartile. So in our case, the third quartile is this one, it's 71.5, and then the first quartile is 61.5, so I just take these values, 71.5 minus 61.5, which gives us 10. Okay, and we are going to use 1.5 of the IQR to detect outliers. So I will just calculate it again. 1.5 IQR is 1.5 times 10, which is 15. Okay. Now let's see if we have too small or too large values. We will start with the lower boundary for this outlier detection. So I will use L. So it's Q1 minus 1.5 IQR. Okay. We know that Q1 is 61.5. We have 15 here, so we can find out it's 46.5. And then if we check, do we have any values that are below 46.5? We can't find any, so we don't have any extremely small values. Similarly, we calculate the upper boundary for the outliers. We take Q3 plus 1.5 IQR, which is the Q3 is 71.5 plus 15, it gives us 86.5. Then we can see that also we don't have any extremely large values, so we don't have any outliers, so we can just work with the data as is. Okay. Now let's make some plot. So this is the dimension. Then we have, for example, we have 50 here, 60 here, 70 here, and 80 here, and then also some the middle points. So now I can plot these values. The first is 53, is somewhere here. Then we have 60.5 and 61.5 and 62. It's 3 points pretty close to each other in this area. Then we have 66 and 67. Then we have 71 and 71.5, 71 and 71.5, and then we have also 74 somewhere here. Okay. Then finally we have 81.5 is here. So this is our data. Now let's make the box plot. This is our minimum value, so I'll just write it like this. This is our maximum value. Then we have the first quartile, it's 61.5, so it's somewhere here. Then the third quartile is 71.5, it's this one. Then finally, the median is in between, so it's this one, it's a second quartile. So I will just write it down. This is mean, this is Q1, this is Q2, this is Q3, and this is max. So now we are ready to make a box plot. That will be the box. This one, this is our median value. And then we have the one whisker for the maximum, and then one whisker for the minimum. So that's our the box, and then you see that the box plot shows that the distribution is pretty symmetric. And if you look at this, indeed, we have a symmetric distribution, even though we have some gaps. Look, these are 2 points in the middle, it's a center, then we have 3 points and 3 points here, and then we have 1 point that are more distanced than the others. So the box plot shows us exactly what we expected to see. And imagine that we have like thousands or hundreds of values. In this case, dot plot will not be very efficient because the points will be overlapping, and box plot will do a very good job in this case.